Hi everybody, thanks for being here after a long day of great talks. My name is Adria Mercader, and I'd like to talk to you about continuous data validation and hopefully get you excited about it. I'm a developer. I work for Open Knowledge International. I spend a lot of time on GitHub, so if you ever interacted with this parrot in an issue or a pull request, that was me. I'm also on Twitter at @amercader, where sometimes I tweet about open data and my work at Open Knowledge. Open Knowledge is a non-profit that was founded in 2004 with the mission of opening up all public interest information and deriving insight and knowledge from it to have an impact on people's lives. To do so, we build tools and communities around things like data literacy or data publication standards or thematic areas. And just to give you a sense of the range of projects that Open Knowledge is involved with, on the data literacy front, we have the School of Data Fellowship Program that has helped teach data skills to hundreds of people around the world. We have Open Trials, which is an open and linked database of all data and documents related to clinical trials that is accessible to researchers, doctors, and patients. The Global Open Data Index is a crowdsourced survey of the state of open data around the world. It's performed yearly, and actually the 2016 edition has gone out live today. And Open Spending is a really mature and well-established project for it's a community and a collection of resources around the publication of financial data, like budgets and spending data. I encourage you to check our website to learn more about this and other projects that Open Knowledge is involved with, but one I will talk about a bit more because I'm more involved, so it gets its own slide. It's CSVConf. CSVConf is an open source software for publishing open data that powers many open data portals around the world, from national instances like data.gov here in the States or Canada to more regional and local ones, but also it's used by universities or research institutions and museums to publish their open data. Its development started quite a few years ago, and during all these years, Open Knowledge has helped deploy and customize a lot of these instances. And from our work with lots of organizations around the world and our exposure to different data publications flows, all this has highlighted what we call the friction involved in working with data. Right from one end of the process where data publishers are trying to make data available online to as many people as possible, to the other end where people is trying to use data, it's a pain to work with open data, as has been highlighted on many occasions during today's talks. There are issues about data being difficult to discover or to find. Data is difficult to export from one system to another, or there's a lack of schemas and conventions that allow you to compare or import your data set directly into your own tool. And perhaps the most pressing issue, as again has been highlighted many times, is that data is in many cases poorly structured and it has a low quality. So even when you find it, you have to spend quite a lot of time cleaning it up and tweaking it so it can be imported into your own tool and use it for your own needs. And this is a process that this is a problem that has no immediate solution and has to be tackled from different fronts. But to help address some of these issues, at Open Knowledge we started a couple of years ago a project called Frictionless Data, which, as the name implies, it's all about removing at least some of the friction in working with data. The two main goals is to improve the way in which data is shared, consumed, and analyzed, and at the same time to make easier for publishers to publish good quality data. And to do so, we're acting on two fronts. We're working on a set of specifications and standards with a strong emphasis on them being lightweight and easy to adapt to existing data, and that build on top of existing best practices. And on the other hand, we're building tools on top of these standards that actually have the impact that we want to see on the data publication process. At the core of the frictionless data project is the data package, which builds on the concept of containerization of data, and essentially is a simple packaging or wrapping format for packaging data in order to make it interchangeable between people and tools. We believe that this abstraction between the actual contents of the data or the format of the data and the tools that it's using it, can have a similar impact to the one that technologies like Docker has had on application deployment and development, essentially by decoupling the data producers from the data consumers by providing this simple common interchange format. How do these data packages look like? So here's an example of a tabular data package, which is a specific profile for packaging tabular data, which is stored on one or more CSV files. On one hand, we have the CSV or CSV, from multiple files as well. And next to them, we have the data package descriptor, which is a data package.json file, which contains basic metadata about the data, like the title, keywords, license, contact info, and of course the pointers to the actual data files or resources. Also embedded on these data resources, you can make use of another really powerful specification, which is the table schema, which is used to describe the actual contents of the data, so how this data is expected to look like. It allows you to define things like the name of the fields or what type these fields are, things like numbers, dates, strings, etc. But also constraints on the fields, like things like this field is the primary key for this file or data set, or this numeric field can only go from 0 to 100, or this string can only have a value which is one of these predefined set of values and things like that. And that's pretty much it. So the combination of data on one hand and this data package.json on the other is what forms the tabular data package. And these descriptors are really easy to do, to create. You can make them by hand or using an online helper that we created, or more likely some tool or integration will create them for you. But what's exciting, of course, is once we have this common layer that wraps different data into the same interface, what's exciting is the tools that we can plug into it. So I don't have time to go through all the tooling that we're working on frictionless data, but just to mention that there are libraries to export and import data packages, for instance, from and to R or SQL databases or BigQuery. There's the data package pipelines framework that can be used to transform streams of tabular data, and of course there are validation tools as well. As I said, data quality and validation is a huge topic that will gain more and more importance as we go forward. So one of the most important pieces of the frictionless data toolset is the good tables validation library. It's a library to perform checks and validate tabular data. It has implementations on Python and JavaScript, and essentially it can run two types of checks. First, the ones we call like structural checks, or look for structural errors, things like extra columns or missing headers or duplicate rows or blank rows, things that affect the actual structure of the CSV. But also, if there's one provided, it can validate the data file against a schema. So it will look for things like the ones I mentioned about the field types, etc. So it will raise errors like on line 321, this field was supposed to be a number, but someone wrote a comment on it. Or this date does not adhere to the format that was predefined, or things like that. And this works really well. It's used on different projects and in different contexts, and there's a You can import it on your own scripts. There's a command line interface to perform these checks. There's even an online tool built on top of it where you can upload the CSVs and it returns you a report with the errors. But all this is still a manual process. So if we really want to bring data validation to the foreground and making it a default on the data publication process, manual checking and manual validation is not going to be enough. What we need is automatic, continuous data validation. We believe that data publication can benefit much in the same way as the software development has benefited from services like Travis CI or Circle CI. For those who are not familiar with them, these services work by running a predefined set of tests against code base. So every time that code is pushed to a repository, these services run the test and provide feedback to the developers about whether the test passed or not. So this gives developers continuous feedback about whether the code is working as they expected. And the same principles can apply to the data publication process. So whenever data is updated, checks should run, and if they fail, data publishers should get this feedback as soon as possible to identify the data issues early in the process and fix them as they appear. This regular feedback will lead to better data quality by ensuring that the data adheres to what it's expected to be. And also, crucially, it will ensure that this quality is maintained over time, even if different tools or persons are involved in the data publication process. And at the other end, of course, for the data consumers, for users, it gives a reassurance that the data is well structured and that can be relied on for analysis or for using it for your needs. So we are really excited about this concept, and to bring it forward and make it possible, we've been working on a service that does exactly that, and we hope that will bring continuous data validation to everybody. It is called goodtailors.io, and it builds on top of well-established and mature frictionless data tooling, and is basically designed to connect to different data sources, and whenever data is updated on these sources, validation jobs will run, and the data publishers will get notified if the data is incorrect in some regard regarding to these checks. For the first initial beta version, we are focusing on data that it's stored on GitHub and on Amazon S3, but we definitely want to explore new integrations and seeing how this can be extended, that can be useful to more publishers and more users. So let me give you a quick tour. Once you sign up and log in on the system, you get a simple dashboard with your data sources that shows the result of the last validation job run on each of these sources. There's a link to a page to manage these sources, so adding new ones and removing them. And for Amazon S3, adding a new source implies like providing an access key, an Amazon access key, and the bucket name. And for GitHub, it's a really similar process to similar services, like when you authorize the application and you synchronize your organizations and repositories. And once you get the list of repositories, you flip the switch on the ones that you want to validate. And then under the hood, the service calls the necessary APIs and sets the relevant hooks. So whenever a file is updated on the Amazon S3 bucket, or a commit is pushed to the GitHub repository, or a pull request is created, a validation job is run, and feedback is provided. On the GitHub case, then goodtailors.io becomes just another GitHub check, and the results are displayed on the user interface, and they can block merging pull requests if the repository is configured like that. And of course, you can add the cute little badge on the README to show that your data is valid or not. This is an example of a report, a failing report. Apart from general information about the job, like who did the commit or who pushed to what branch or the commit message, etc. There's a report below with the errors grouped by error type and a preview of the rows that are failing to give a really immediate feedback to the data publisher. We definitely want to improve this by adding better descriptions and even if possible give suggestions on how to fix these problems, so they can be easily fixed on the dataset itself. And the validation will run the two types of checks that I mentioned before, so structural checks, and if there's schema provided, either with a separate file or embedded in a data package, it will also validate against the contents of the file. Just to be clear, you can run the validation against any repository that has tabular data, like CSV or Excel files. But of course, if there's a schema provided, either separately or embedded, the test will be more thorough and consistent with what the dataset is expected to be. To further control the validation process, there's an optional goodtables.yaml file where you can define things like where the data is located, where the schema is located, and things like what the delimiter is for CSVs or what rows to skip, etc. If there's no YAML file defined, the service will look for a data package.json file, and if you can find one, then again, it will look for all the tables on the repository and just run the validation against them. That's pretty much it at this stage. Just to give you an idea of what we've been thinking about introducing in the future, maybe just paid plans to make the service sustainable that enable extra features like private repos or things like that. New integrations with other backends, things like Google Drive, Dropbox. Dropbox, I think, is one particularly worth exploring because it could target a whole new set of users or organizations where they're more familiar with desktop tools, that is cloud-based systems, and also could lower the technical entry barrier to this kind of tools. But also, we definitely want to enable API access to the service so it can be integrated to any custom workflow or tool, essentially by sending a file or list of files to the service and getting back a report of the validation report. And that will hopefully enable people to integrate it on their own workflows, on their own tools, or on tools like catalogs like CSVConf or others, and make data publication just another normal part of this data publication process. I think that's pretty much it at this point. I really encourage you to give it a go, goodtables.io. It's early stages. There are a lot of rough edges to polish, so bear with us. There's a link at the header of the application to give us feedback that links to this thread on our forum. So please add any comments there that you think that are worth raising. We are also on Gitter if you want to have a chat. And of course, myself and my colleagues will be around for the rest of the conference, so grab us if you want to have a chat. And yeah, that was it. Thank you very much. Any questions?
So how are these schema rules actually defined in the JSON? SQL statements or something?
No, there's just JSON objects. Sorry, it's not my computer, so I'm not sure how to show you one. But anyway, it's a JSON file with one of the keys being schema, and one inside the schema there's an array of fields, and each field is an object that says type, date, format. This. So I can definitely point you to the schema now and show you examples of it. Any other question?
Is there any more advanced tests besides just like looking whether it matches the schema? Can you make more advanced custom rules?
Just give me an example, for instance.
I don't know, like looking for like near misspellings or something.
Not built in on the library that underlies this, which is good tables, but this library is extensible, so you can provide your own checks. So we can definitely look at a way of integrating this or making this customization, expose this customization and allowing users to provide their own checks. And that could be actually really, really powerful, especially just for checking for spelling, as you said, but also on, for instance, on research data to make sure that, I don't know, standard deviation doesn't go from these margins on a particular column or things like that. So that could be also really powerful, yeah.
In the same vein, is there a way to do like combinatorial checks, like these three columns can't have these, like this combination of these three things can't happen? That's you know what I mean? Instead of
Yes. I don't think that's possible now, but it's a great idea to raise on this thread. So. Any other question?
Well, first of all, we also would like to include our own validation. We use data packages, but we have our own validator because we need extra things on top of that. And so that's, I think, something that a lot of people would like to see. And on top of that, I just tried it out, but I can't see the things in my GitHub organization. Is there a thing that you are aware about and want to implement?
That sounds like a bug. Thank you for pointing to everybody.
At one point, the thing about custom checks is
it's hard.
if you use the lower level library, like the Python library, it's really easy to add custom checks. So you could add pull in a spelling thing, or you could custom, check multiple columns as was suggested before. But yeah, there's a difference between the lower level Python library and then the generic web stuff.
Yeah, but would the generic website be able to use my extension of the library? That would be nice too. Not yet, no.
Not yet. If you can solve the problem of how to do it, yes, absolutely. It's not an easy problem, but yeah.
It's a nice interface.
Yeah. Cool.
Is there a command line tool for running these checks locally?
Yes, definitely. I mean, so GoodTables.io is the service, but the library GoodTables is, you can run it locally, and there's a command line to run these checks, yeah.
So and if you're running the command line locally, then you can use
The custom checks, yes.
the Python library.
Yes.
Just not with the web.
Yeah, exactly. Anyone else? I think we're done here.
Great.
Thank you very much.